Hello, chemists. This is Miss Placino. Sorry I'm not going to be able to be with your class today. You guys will be working on virtual lab number 6, precipitation reactions. So the lab itself isn't on Jupyter. It should be in the Unit 5 packet, and it's just like the front and back of a page. So I want to just kind of discuss a couple things before I, kind of set you off to work on these on your own without me being there to help. I want to start with the post-lab questions. Question 1 is asking you to write a dissociation equation for each of the compounds that are used in this lab. So there was a little bit of confusion about this with my previous classes, so I figured I'd just go over this. Remember, dissociation equations are just you taking that ionic compound, dissolving it in water, and ultimately that will cause the ionic compound to break apart into ions. If you look back at your 5.5 notes, this was like kind of the first step of a double replacement reaction. So that H2O above the reaction arrow means dissolved in. You're not going to react water with zinc chloride in this case. You're just going to use that as a solvent and dissolve this compound. So when zinc chloride breaks up, we're going to have zinc ions and chloride ions. We can use the reverse crisscross method in the periodic table to predict the charges of each. Zinc is always a 2+. Chlorine, when it becomes an ion, will gain an electron to become chloride. We want to write a balanced dissociation equation. So I've got 2 chlorides on the reactant side. Now I also have 2 on the products. You might be wondering, well, what did we do with the water? Well, these are now aqueous ions. You can include that as well. This lab should be a really good review of double replacement reactions. I tried to incorporate some naming in there, all to help you prep for the test. So you can do these post-lab questions, question 1 anyway, either at the beginning or the end of the lab. It doesn't really matter. To get up to the lab itself, here's what I'd like you to do to try to make this a little bit easier to follow along in the virtual lab. Go ahead and start to label different compounds with just the letters A, B, C, D, E, F, G, and H. You'll see why we're doing this when we kind of get into the virtual lab. Do the same thing in that column, A through H. All right, so basically what you're going to be doing in this lab is running a bunch of very small scale reactions. You're going to have what's called a well plate. It's basically a plate with a bunch of holes in it that you can add liquids to. So we're going to take a mixture of zinc chloride and potassium iodide and react it, zinc chloride and sodium carbonate and react it, and so on and so forth. The droppers aren't labeled with the formulas, they're labeled with these letters, so I thought this might make it easier. Let's do a couple together. Where is it? There it is. Okay, so this is the lab itself. Hit the little green flag to begin. So it's set up the same way as we just did in our grid. I'm going to click on the pipette, click on where I'd like to put it, and I'm going to recommend just kind of going through the entire row with that one pipette. Otherwise, you might drive yourself crazy picking stuff up and putting it back. So I'm just kind of like clicking on the circle. It's supposed to, again, represent a little well of a well plate. Got some in each. Click on this to return the pipette. All right, now I'm going to react B with A. Doesn't look like really anything happened. So there we have a change. So in the grid where you've got reactant A reacting with reactant C, we do have a reaction here. That change in color is supposed to represent the formation of a precipitate. So I would write down like PPT white. Show you what I mean. So nothing there. That's the reaction between C and A. PPT for precipitate. I'm just going to remind myself that it was a white precipitate. Why not? Let's do another one. D, another white precipitate. E, ooh, another white precipitate. The excitement. F, looks like nothing happened there. G, okay, no reaction there. And H. All right, so I can just kind of go back and I've got D, E, and H forming white precipitates. Turn that pipette. And you can either leave the other ones blank or you can write NR for no reaction. And you're going to repeat that process so that you have every possible combination of these 8 reactants and observing whether or not they form precipitates. Once you've got that squared away and you know all of the reactions, there are unknown tests. So you're going to pick a solution, record its code. So we really just mean the letter from this website. You're going to write down what you've observed, and then you're going to try to use your known solutions to figure out the identity of your unknown. So basically you have this entire chart complete. Follow the other link, we'll get you to lab number 6, precipitation reactions. I'm going to pick unknown K. There we go. Okay, so I'm given A through H. So here's what I would do on my end. I would make sure that I have the unknown code written down. Again, it's just the letter of the unknown. And then I'm going to record the observations. So I've got like a white precipitate, yellow precipitate, white precipitate. And no reaction, brown precipitate, white precipitate, white precipitate. Ooh, it's a busy one. And really, however you want to record your observations is fine with me. If you want to use other abbreviations, that is perfectly okay. And then when I'd have this chart completely filled out, I would try to match it up and see which of these compounds is my unknown. And that's really it for the lab. It's a much more fun one to do in person, as always, and I'm really sorry that we're kind of stuck in these circumstances. So we talked about how to write the dissociation equations for question 1. For question 2, you're going to choose 10 of the reactions that formed a precipitate. So for example, choosing something like the reaction between zinc chloride and sodium carbonate, yeah, that'd be a fine one to do since it produces a precipitate. You don't want to pick one between like potassium iodide and zinc chloride because there's no reaction, so you don't actually produce a solid. And you're just going to write it out. It tells you in the directions that you can avoid writing down all the phases. I know that can take up a lot of space and there's not a ton of room there. Just put a box around your precipitate. So we'll go through one together. So you only have 9 left to do. We'll do that first one that formed a precipitate where we had zinc chloride plus sodium carbonate. I'm going to leave myself a little bit of room so that I can balance. 2CO3. So I'm going to use the techniques that we talked about in class to predict zinc carbonate, plus sodium chloride. And I can use table F or my extensive life experience with sodium chloride. I know that dissolves in water, so it seems pretty likely that zinc carbonate is going to be the precipitate. Let's check and make sure we're balanced. 1 zinc, 1 zinc. I need 2 chlorines. Let's put a coefficient of 2 in front of the sodium chloride. That gives me 2 sodium. Oh, we're balanced. You're going to repeat that for 9 other reactions that form a precipitate. And that is the lab. I'm going to use this as kind of proof of you being in class today. So I'm going to expect you to have this uploaded during the class period. I already did one whole row for you. So hopefully, you've got plenty of time to work on this. This is a great way to review and practice precipitation reactions. And yeah, again, I'm so sorry I'm going to miss you today. I'm not able to be in class this morning. If you've got questions, email me. I will be able to probably hold like a Zoom later this week, like during academic assistance, if you want to check in. And I will get information to you about the format of Monday's test out via email. All right, chemists, I'm sorry you're kind of on your own on this one. I know you can do it. Please make sure it gets uploaded by the end of, ideally the period, but end of the day.